Good day, students. You are welcome to your favorite YouTube channel, Physics for Everybody. Today, we'll continue our discussion on work, energy, power, and efficiency. You remember during the last video, if you have watched the previous video, the last video we talked about work and energy. We talked about the formula used for calculating work, and we defined work as the product of force and distance. We solved this first example by calculating work done as being the product of force and the distance. So we multiplied the force by the distance and we got the work done in by the force. And the second example, we also calculated the work done by multiplying the force by the distance. You know, the force is the weight and the distance is the height. And in order to calculate the weight, we have to multiply the mass by the gravitational field strength, okay? And then we multiply that by the distance, which is the height, okay? And by the time we multiplied the mass multiplied by gravitational field strength, we got 400. We multiply that by the height, you get 2000 joules. So those are the formulas for calculating work done. Okay, you use force times distance. If it is a force that is moving along a straight line, okay, you have a force that is pushing an object and the object covers a certain distance. Okay, this is the distance, this is the new position of the object. So you multiply force by distance, okay? And if you have an object that falls due to gravitational field strength of the earth, in that case, you'll be using mgh to calculate work done, okay? If the work is done by gravity, you use mgh. If the work is done by force moving along a horizontal plane, then you multiply the force by the distance. We also talked about energy. We define energy as what makes work to be done. Yes, energy is the capacity to do work. And we talk about different forms of energy. We talked about kinetic energy as the energy due to the motion of a body. Okay, kinetic energy is the energy possessed by objects in motion. And we said the formula for calculating kinetic energy is half mv squared, where m is the mass and v is the velocity. We also talked about potential energy, and we said there are three types of potential energy. The first one is gravitational potential energy, which is due to change in position. The second one is elastic potential energy, which is due to change in shape. And the third one is chemical potential energy, which is usually due to change of state. We also have electrical potential energy, that's due to charged objects. When electric charges are in motion, you have electrical potential energy. And when it comes to gravitational potential energy, the formula for calculating gravitational potential energy is mgh. Take note that energy is measured in joules, okay, just like work done. Work is also measured in joules. Yes. Hence, you take note that take note of a similarity. The formula for calculating gravitational potential energy is the same formula for calculating work done when an object falls due to gravity. Yeah, good. So you can say the energy is being used in doing work. The gravitational potential energy will be used in doing work in bringing that object downwards. Elastic potential energy, and the formula for elastic potential energy is let me put it here. Elastic potential energy is half F E, where F is the force and E is the extension of the elastic material. Another formula we can use for elastic potential energy is half Ke squared, where K is the spring constant or stiffness of the spring and E is the extension of the spring. We talked about transformation of energy when energy is converted from one form of to another. For instance, this electric fan converts electrical energy to kinetic energy. Okay, so the energy supplied by from the plug The energy supplied from power supply unit is converted to kinetic energy. That is when air molecules are sent out in motion and the air molecules are given some kinetic energy, and that is conversion of electrical energy to kinetic energy. Also, the electric system, the electric speaker in your house, they convert electrical energy to sound energy. And that sound energy, it's due to air molecules that are also in motion. Yeah. So that's the concepts we discussed. We talked about the conversion of gravitational potential energy to electrical energy by your dam. Yeah, when water at a certain height is made to rush out when it falls due to gravity. Yeah, take note that there is a certain height. The dam is always placed at a certain height. All of this has been discussed in the previous video. You can watch it for detailed explanation, okay? But let me just do this. Let's assume that this is the dam and the dam contains water. So we have an outlet, and because of the height of that dam above the ground level, this ground level, so there's a height of the dam above ground level. Hence, the water would be forced to rush out, okay? Because gravity is bringing all water molecule downwards, okay? So that gravitational potential energy will be used in turning the blades of of the turbine, hydroelectric turbine. There is a blade here. Yes, it has veins that vein that help convert the kinetic energy of of the water molecules. It converts it to rotation of this vein, and when this one begins to rotate, there will be a shaft connected to an electric coil that rotates. That electric coil is in a magnetic field, and when you have a coil rotating in magnetic field, there will be electric current. Yeah, so we talked about useful energy. When we were talking about useful energy, we're trying to talk about the efficiency of a system. And when we talk about efficiency, efficiency is equal to useful energy, okay, usually the useful output energy divided by the total input energy. Total input energy. That is the formula for efficiency. Is always expressed in percentage by multiplying by 100%. This will always give us the efficiency of a system. And every system can be represented with an energy diagram. Take note that the energy diagram is also called a Sankey diagram. And the energy diagram usually looks like this. You have an arrow going downwards or upwards. The arrow that branches shows energy that is wasted, while the arrow that goes straight shows us the useful energy. In this case now, let's give an example of we can use this for example. You can use this as an example. You can use this. Let us use this, the fan. So the fan receives electrical energy and it converts it to kinetic energy of air molecules. So the input energy is electrical energy, and the output is the kinetic energy of the air molecules. Kinetic energy. While the wasted energy in this case, the wasted energy is the heat energy, and that is what happens when you touch the coil of the fan. You touch the coil of the fan, it will be very, very hot. Yeah, so the wasted energy is the heat energy. Let us assume the electrical energy input is 100 joules, and the kinetic energy you get is 70 joules. That means the wasted energy would be 100 minus 70, that's 30 joules. That means the heat energy that is wasted is 30 joules. And if you want to calculate the efficiency, take note that the kinetic energy is the useful energy because that's what you need from the fan. Yes, ability of the fan to convert electrical energy to kinetic energy, that's what you need. So if you want to calculate the efficiency now, You divide the useful energy, which is 70 joules, okay? 70 joules is the kinetic energy, and that's the useful energy in the fan. You divide it by total energy, which is electrical energy input. Electrical energy is 100 joules. Then you multiply it by 100% in order to express it in percentage. This will give you 70%. Hence, it means this fan is 70% efficient. Okay, so these are other examples of energy conversion. The television converts electrical energy to light energy, sound energy, and heat energy. Take note that this heat energy is wasted energy because you don't need it in your television. All we need from your television are light and sound. Also, your radio converts electrical energy to sound energy and heat energy. The heat energy is wasted energy because we do not need it. So also your car, when you put your fuel in your car, your fuel contains chemical energy, and the fuel will be used in setting your car in motion. So your car moves forward with a certain velocity. That means it possesses kinetic energy given by the formula half mv squared. But the point I'm focusing on is that your car has kinetic energy, it produces sound which is undesirable, it also gets heated up, it produces heat. The heat is undesirable when it's a sunny day and everywhere is hot, okay? Unless you are freezing and you don't even, the heat is completely undesirable in a car. Yes, we do not need the heat produced by the engine. So the heat is wasted energy. The sound is also wasted energy. So that is what happens in the case of a car. Yeah, and if you decide to draw the Sankey diagram of the car, you have chemical energy as the input, okay? Then some energy will be wasted in what form? In the form of heat, okay? Then also some energy will be wasted in the form of heat. Also, some energy will be wasted in the form of sound, and the output goes this way. So the output is the kinetic energy of your car. Okay, the input is the chemical potential energy contained in the fuel. The wasted energy is sound energy. Also, the wasted energy is heat energy. This is what the Sankey diagram, okay, or energy diagram of a car looks like. These are other examples. There's an example of a filament lamp and another example of an energy efficient lamp. Okay, if you go through it, you see that the input energy is 100 joules, the wasted energy is 90 joules, while the energy converted to light is just 10 joules. Yes, that's why the filament bulb is considered inefficient. Why? Because much energy is wasted. If you calculate the efficiency, you do useful energy divided by total input energy multiplied by 100%. This will give you 10% efficiency for the filament lamp. For the filament lamp, yeah. And if you try to do it with the energy efficient light bulb, which is the second one here, the output energy, which light energy, is 10 joules. The total input is 20 joules. So if you do 10 divided by 20 and you multiply it by 100%, you get the efficiency to be 50% efficient. So if you use a calculator to calculate this, you get 50%. Okay, that means the energy efficient bulb is more efficient when you compare it with the filament bulb that has an efficiency of just 10%. Okay, good. So that is a point of emphasis. Now we go straight to the law of conservation of energy. According to the law of conservation of energy, it states that energy cannot be created or destroyed. Okay, but energy is changed from one form to another. What does that mean? That means if an object possesses one form of energy, it can change that energy to another form of energy, and that is all we've been talking about so far. Think about your car. it converts chemical energy to what form of energy? It converts it to kinetic energy. It also converts it to sound energy and also converts it to heat energy. So this chemical energy is not destroyed, but it has only been converted to three other forms of energy. That is what we mean by conservation of energy. It means the energy is not destroyed, but it is changed to another form. Okay, that means energy does not disappear and total amount of energy is always the same. Okay, though some of the energy would not be useful to you, but total amount of energy would eventually be the same. Okay, and energy is transferred to several different forms. Okay, some of them may not be useful. So that is what the law of conservation of energy is trying to make us understand. Now look at this. Falling objects possess gravitational potential energy, but as they are falling, the gravitational potential energy would be converted to kinetic energy. What does that mean? Let's use this space for visual representation. Let's assume you have a big table, okay? These are the legs of the table. Now you have a big table and you have a ball placed on this table. Okay, this ball is on this table, is at rest. Okay, but take note that this ball is at a certain height above the ground. It's at a certain height h above the ground. So because of the position of this object, it possesses what form of energy? It possesses gravitational potential energy. And the gravitational potential energy is given by the expression, the mass multiplied by gravitational field strength multiplied by the height. But if for any reason this table is moved away so that the ball will be left hanging on nothing, what will happen to the ball? Since there is no support holding the object in place, then the ball begins to fall. It falls downward. What is happening while it's falling? The gravitational potential energy is being converted into kinetic energy. And kinetic energy is given by the expression half mv squared. So take note that while it falls at this point, okay, midway in its journey, it possesses kinetic energy because it's moving. It also possesses gravitational potential energy because it is also at a smaller height h above the ground. Okay, so if you want to calculate the gravitational potential energy at this point now, it is mgh and the small height h. Okay, yeah. While gravitational potential energy at the beginning, at this point, the gravitational potential energy is mgh. At this point, the gravitational potential energy is mgh, the big H. Okay, let's assume the big height is 50 meters. So you multiply mass times gravity times 50. But at this point here, the gravitational potential energy will be mg times small h. If the small h is 10, then you have mass times gravity times 10. That will be the gravitational potential energy. Okay? While in the beginning, the gravitational potential energy will be mass times gravity times, we assume the height is 50 times 50. Good. So at this point, midway in its journey, it possesses both gravitational potential energy and it also possesses kinetic energy. Why? Because it is moving downwards. It is moving downwards with a speed v. Okay? So, but when it is about to land, when it eventually reaches ground level, at ground level, it is no longer at any height above the ground. At ground level, the height is equal to 0. That means the gravitational potential energy at ground level is equal to 0. Okay? Hence, all its gravitational potential energy has eventually been converted into its kinetic energy. Okay, so at ground level, it has its maximum velocity. Okay, the velocity will be highest. Why? Because as it's falling downwards, it's being pulled downward by gravity. Hence, the velocity continues to increase as it's going downwards. And when it's about to land, it has maximum velocity. Then it eventually lands on the ground. And all its gravitational potential energy would have been converted to kinetic energy. But when it eventually touches ground level, all the kinetic energy that it possesses now will now be converted to sound. You know, when it hits the ground, it produces sound. Okay, it also produces heat due to friction. Yes, when it hits the ground, it also produces heat. So that's what it means by conservation of energy. Energy is changed from one form to another, but the energy is not destroyed. It has only been changed from one form of energy to another form of energy. Okay, so if you look at your roller coaster, at this point, at this topmost point, it is at a certain height above the ground, H. So at the topmost point, it possesses gravitational potential energy. That gravitational potential energy will be converted to kinetic energy as it slides downward along the rail. Okay, as it moves along the rail, its gravitational potential energy is being converted to kinetic energy. That's what we mean by conservation of energy. Okay, good. So the gravitational potential energy lost equals to kinetic energy gained. Yeah. So the gravitational potential energy lost by the roller coaster in falling downwards, okay, in falling from that point, in sliding downwards, all the gravitational potential energy will be converted to kinetic energy at the bottom of the rail, at the lowest point. Okay, hence the roller coaster continues to move forward, and that is what the law of conservation of energy teaches us. Take this example, for instance, a light bulb converts 10 joules of electrical energy into 7 joules of light energy and 3 joules of thermal energy. Take note that the thermal energy is the wasted energy. So from this statement, we can say that the amount of energy at the beginning is equal to total sum of energy at the end. Yeah, so the fact that the useful energy is lower than the total input energy does not mean that energy has been lost. No, the thermal energy has not been lost. Sorry, it does not mean energy has been destroyed rather. The thermal energy has not been destroyed. It has only is only in the form that is not useful to you. Okay. If you were to calculate the efficiency, that's the useful energy divided by total input energy multiplied by 100%. That simply means this bulb is 70% efficient. Okay, good. That is the point. So there are other examples, this like the case of the hand drill. Okay, some energy is also wasted in the form of sound and heat. Okay, good. So there's a question for you. Which devices waste energy as heat? That's a question for you. All the devices here waste energy as heat. When you plug your phone and it is charging, after some time it becomes hot. It's wasting energy in form of heat. Your television, when you use your television, after some time, go and touch it. It feels hot. Even your radio, after some time, it produces heat. It's just that the heat is always so small that you won't notice it when you touch it. But trust me, it's producing heat. As for your car, the heat is so great that you even need to pour water in the radiator of your car in order to prevent it from becoming overheated. Okay, I'm sure we've talked about the energy dissipation by the bulb. Okay, it converts electrical energy to light energy while the heat energy is being spread out. The heat energy spreads out into the surrounding, hence you cannot tap it, you cannot use it for any useful work. Okay, but it exists. So the total energy is always the same. Okay, but some energy are in a form that are not useful, and that is the heat energy. So what is the point when we are talking about efficiency? Efficiency talks about how energy is being conserved. Okay, if something is not efficient, then it's wasteful. It's waste energy. The more efficient a device is, the less energy is wasted. So if something has low efficiency, then it's converting much energy to a useless form. Okay, and if something has high efficiency, it means most of the energy are in a form that is useful to you. Remember, I presented this formula for efficiency, and if you want to express it as a percentage, you multiply by 100%. Okay, but if you don't multiply by 100%, the efficiency will be in decimal form, and it will be in values ranging from 0 to 1. Look at this example. A filament bulb is supplied with 100 joules of electrical energy. Which it converts to 45 joules of light energy. Okay, you can see this is the useful energy, light energy. So if you were to calculate the efficiency, just divide the useful energy by total energy supplied, you get 0.45. And if you're expressing it as percentage, that means you multiply this by 100%. Once you multiply this by 100%, you get 45% as the efficiency of the bulb. This is another example. The radio is supplied with 300 joules of electrical energy, which is converted to 96 joules of sound energy. How much energy is wasted? If you subtract the 96, if you do 300 minus 96, you get the wasted energy as 204 joules. Okay, in what form is the heat energy? Sorry, in what form is the here it should be D. In what form is the energy wasted? And the energy is wasted in the form of heat. Now you have to calculate efficiency. What will you do? You divide the useful energy by the total energy. Okay, so you do 96 divided by 300, you get 0.32. If you want to express it as a percentage, then you're going to multiply it by 100%, and that will give you 32% as the efficiency of the system. The third example is your television. Okay, so I would like you to solve this question yourself. Yeah, this television converts 2000 joules of electrical energy into useful energy at an efficiency of 65%. What useful energy does the television produce? Of course, the television produces light and sound energy. How much how much useful energy is produced? No, you see, this is the efficiency, right? So how will you get the useful energy produced? Useful energy is efficiency multiplied by total energy. So now you multiply efficiency by total energy and tell me what you get. Pause this video and solve it yourself. Then you compare your answer with mine. Pause the video now and solve it. Alright, so I'm gonna solve it. Useful energy is your efficiency, which is 65%. You multiply it by 2000 joules. Take note that percentage means per 100, okay? So instead of writing percent here, I can write it as 65 over 100, okay? And then I'll multiply that by 2000. You get it? Good. So that is what we are doing here. So when I divide 65 by 100, I get 0.65. By the time I multiply 0.65 by 2000, you get 1300 joules. So that is it, and that is the point we're trying to make here. Now we're going to be solving questions on work, energy, and power. Let's go. But before we solve the question, let us have a review. Work is equal to force times distance, where W is work done in joules, W is the work measured in joules, F is the force measured in Newton, and D is the distance measured in meters. And this is a visual representation of the formula, okay? Work is force times distance. Force is work divided by distance, and distance is work divided by force. This is also a visual representation of the formula. Question 1. Now let's start solving. This is easy. In fact, you can pause this video and solve this yourself. Now I solve. Calculate the work done when a force of 5 Newton moves through a distance of 3 meters. What's the formula for work done? Force multiplied by distance. What is the force? 5 Newton. 5 multiplied by, what's the distance? 3 meters. 5 multiplied by 3, you get 15 joules. Easy. Calculate the work done when a force of 6 Newton moves through a distance of 40 centimeters. What's the formula for work done? Work done is equals to force multiplied by distance. What is the force? The force is 6 Newton. Good. What's the distance? The distance is 40 centimeters. We don't calculate distance in centimeter. We use distance. Our distance must be in meters. So we have to convert our distance to meters by dividing by 100. Yeah. When you want to convert centimeter to meter, you divide by 100. You get 0.4 meters. That's your distance. So you get back to your formula for work. Work is force. Your force is 6 times distance. Your distance is 0.4. 6 multiplied by 0.4 will give you 2.4 joules. That's the work done. Easy, right? Yeah, of course it is easy. Now try solving question 3 yourself and you check if you get 12 Newton. Pause the video and solve. Alright, question 3. Calculate the value of the force required to do 600 joules of work over a distance of 50 meters. What's the formula for work? Work is force times distance. Now let us substitute. What is our work done? The work done is 600 joules, okay? So we write 600. Let me conserve space. So you write 600 is equal to force. What's our force? Our force is the force is not given. You have to calculate the force, okay? Assume this is not here, please. This is just for you to check whether you are correct, whether your answer is correct or not. Calculate the value of force. You don't know the value of the force, so we put F here because we don't know the force, okay? Multiply by distance. What's our distance? The distance is 50 meters, so you multiply by 50. Now, F times 50 gives 50F. So if 50F is equal to 600, how will you get the value of F? You divide both sides by 50, okay? You divide both sides by the coefficient of F. So we are dividing both sides of this equation by 50. By the time you divide 50F divided by 50, you get F. 600 divided by 50, you get 12 Newton, and that is your answer. I hope this is what you got when you solve this yourself. All right, guys, let's move to the next one. So we keep solving, okay? You keep solving, solving, and solving. Calculate the distance moved by a force of 8 Newton when it does 72 joules of work. How you do that? You start by writing your formula. Work is equal to force times distance. You can pause this video and solve it, please. What is the work? Work is 72 joules. So we write 72 is equal to, what's the force? Force is 8 Newton. 8 multiplied by, what's the distance? Calculate the distance moved. You have to calculate the distance. So the distance is not given. So we write D here because the distance is not given. Okay. So we can, that means 72 equal to 8D, right? Good. So you can also write this by like this. You can write it as 8D is equal to 72. If 8D is equal to 72, how do you get the value of D? Divide both sides by the coefficient of D. The coefficient of D is 8. So when you divide both sides by 8, 8 will cancel out 8. You'll be left with D on the left-hand side. D is equal to 72 divided by 8. You get 9, okay, as the distance. And the unit of distance is meters, 9 meters. Done. Easy, right? Good. Now let us solve this one. Calculate the work done by a child of weight 300 Newton who climbs up a set of stairs consisting of 12 steps, each of height 20 cm. The best way to solve this, we need to have enough space. The best way to solve this is to write out your values. First of all, you have to calculate the work done. What's the formula for work done? Work done is force multiplied by distance, right? What is the force? The force is 300 newtons. What's the distance? The distance is the height. And what's the height? The height is 20 cm. Okay? Take note that there are 12 steps. Okay? There are 12 steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each of these 12 steps is 20 cm each. 20 cm. So what will be the total distance from the top to bottom? What will be the height of everything? To get the height of everything, just multiply your 20 by 12, okay? And that will give you 20 multiplied by 12, 12 times 2, 24. That will give you 240 cm. Take note that distance must be measured in meters. So you are not using distance in cm, you are using our distance in meters, okay? So our distance is 240 divided by 100, and that will give us 2.4 meters. That's the distance, right? Good. Now let's go ahead to solve it. This diagram is not part of the answer, okay? So we can wipe it off. So we have enough space to solve the real problem. Formula for work is force times distance. So work is equal to force. What's our force? Our force is 300 Newton. What is our distance? Our distance is 2.4 meters. 2.4 meters. 2.4 multiplied by 3, you get 7.2. So that means 2.4 multiplied by 300 will give us 720 joules as the work done. Is your answer correct? Yes, your answer is correct. Let us move to the next one. Calculate the work done by a person of mass 80 kilogram who climbs up a set of stairs consisting of 25 steps, each of height 10 centimeters. How do you calculate the work done? The formula for work done is force multiplied by distance. Take notes that we don't have the force, we only have the mass. So how do we get the force here? The force is equal to mass multiplied by gravitational field strength. Yeah, okay, good. And how do we get the distance? The distance is equal to the height, which is 10 centimeters times 25. You took 25 steps each of 10 cm. So we multiply 10 cm by 25. Okay, that means the height is equal to 10 times 25 will give us 250, right? Centimeters, 250 centimeters. Convert to meter. When you want to convert to meter, you divide by 100. Okay, and if you divide 250 by 100, you get 2.5 meters. Now we can calculate the work done by saying work done is equal to your force. How do you get force? Mass times gravitational field strength to give you the force, okay? Multiply by your distance. What's the distance? The distance is the height, okay? So multiply your mass. What's the mass? The mass is 80 kilogram, 80, multiplied by g. Gravitational field strength is always taken as 10. Yeah, 10 meter per second square for IGCSE level. Yeah, and your height is 2.5, which you just calculated, 2.5. If you multiply 80 by 10, you get 800. Multiply 800 by 2.5, you get 2000 joules. Okay, you can confirm this by multiplying this with your calculator. No, no, okay, yeah. So this is a classwork for you. Okay, you can pause the video now and solve this question. Okay, so this is how you solve the question. Question number one, you have to calculate work done. That's why no value is here. Okay, you are given the force as 50 newton, you are given the distance as 3 meters. So use your formula to calculate the work done. Okay, whichever answer you get, you put it here. Okay, whichever answer you get, you put the answer here. Question number two, you have to calculate the force. That's why the force is not given. Calculate the force in Newton. You have the work, you have the distance. Question number three, you have to calculate distance. Question number four, you calculate the work in kilojoules. Okay. How do you get work in kilojoules? Once you get your answer in joules, divide it by 1000. That will give you your work in kilojoules. Okay, so you can solve all of this yourself. And question number five, you have to calculate the force in Newton. The work was given to you in megajoules. Take note that 1 megajoule is equal to 1 million joules. Okay, that means these 2 megajoules will be 2 million joules. So you can solve this question now. So pause this video and solve all these 5 questions, and you compare your answers with what you see on the next slide. Thank you. So these are the answers to the questions. If you have solved them all, this is what you should have gotten. Okay, if you have made any mistake, your mistake must have been on this distance, 5 kilometer. Okay, you convert to meter by multiplying by 1000. Okay, so if you have multiplied this 5 by 1000, you get 5000 meters as the distance. So if you use 5000 meters, 5000, if you divide your 2 million joules by 5000 meters, you would have gotten 400 Newton as your answer. So that is it. Let's just have a quick review before we take the next part of this lesson. Okay, good. You may pause the video now and go for a break. Okay, I don't want to break this video into two. Okay, so that you can all take it as a single lesson. Gravitational potential energy is given by the formula m times g times h, which is mass times gravitational field strength times height. Okay, good. Your mass is measured in kilogram. Your gravitational field strength is measured in Newton per kilogram or meter per second squared. Those are the two SI units of G, okay? And H is your height in meters. Good. So now this is a question for you. I'm sure you can solve this now after going through all of that. Yeah, you keep solving. You just solve and solve and solve. Calculate gravitational potential energy gain when a weightlifter lifts a mass of 120 kilogram up by 2.5 meters. How you do that? Your gravitational potential energy is equal to mgh. What's the mass? 120 kilogram. What's the gravitational field strength? 10 Newton per kilogram. Then what's the height? 2.5 meters. 2.5. If you multiply 2.5 by 2.5 times 10 is 25. 2.5 times 2 is 5. 25 plus 5, 30. So if you multiply all of this, you should get 3000. You should get 3000 joules as the gravitational potential energy. Number two, calculate the gravitational potential energy gained by a student of mass 70 kilogram climbing a flight of stairs of height 4 meters. What formula you use for gravitational potential energy? mgh. Let me just write it as mgh. So you calculate it as mgh. What is m? M is the mass, which is 70 kilogram. G is the gravitational field strength, which is 10. H is your height, which is 4. 7 times 4 is 28. So you have 2800 joules, 2800 joules as gravitational potential energy. Okay, so before we go into kinetic energy, take note that the formula for kinetic energy is half mv squared, where m is your mass in kilogram and v is the velocity. Okay, v is the velocity, okay, or speed. Good, in meters per second. So with that, let's solve. Okay, this is an example for you to understand how we solve it. Calculate the kinetic energy of a car of mass 1000 kilogram moving at 5 meters per second. So the first thing you do, you write the formula, then you substitute. Okay, you have half times mass is 1000, so you have half times 1000 times 5. Take note that the velocity must be squared. That's why we're writing it as 5 squared, okay? That's why we got 5 squared here. And when you do 5 squared, you get 25. Good. So that's why the next line is half times 1000 times 25. If you multiply half times 1000 times 25, you get 12,500 joules as your answer. Question number two, you may solve this, okay? Pause this video and solve question two, then you compare your answer with mine. Now I will solve. Calculate the kinetic energy. Kinetic energy equals to half mv squared, and that's equals to half times, what's the mass? Calculate kinetic energy of a child of mass 60 kilogram. Your mass is 60 kilogram, moving at 3 meters per second. Your speed is 3 meters per second, 3 squared. So you get half times 60 gives you 30, okay? So you have 30 times 3 squared, and 3 squared is 9. 30 times 9 gives you 270. So your answer is 270 joules. Question number three. Calculate the kinetic energy of an apple of mass 200 grams moving at 12 meters per second. The formula for kinetic energy is half mv squared, okay? What is m? M is the mass. And what's the mass? The mass is 200 grams. Do you use grams in physics? No. In this topic, our mass must be in kilogram. So you write 200 divided by 1000. That's how you convert to kilogram. You get 0.2 kilogram. Now you can solve the kinetic energy by saying kinetic energy is half times 0.2 times your speed is 12, right? So times 12 squared. Half times 0.2 gives you 0.1. So it will be 0.1 times 12 squared. What is 12 squared? 12 squared is 144. So you multiply this by 144. 0.1 times 144 will give us 14.4. And then you put your SI unit in front of it. Joules. Okay, that's 14.4 joules. Question 4 has been done for us. Calculate the mass of a train if its kinetic energy is 2 megajoules. Let me just take that again. No, it has not been done. Good. So, okay, so just the values have been defined. Okay, calculate the mass. Mass is unknown of a train if its kinetic energy. The kinetic energy is 2 megajoules. So you express 2 megajoules as 2 times 1 million. Okay, that's what was done here. And if you multiply 2 by 1 million, you get 2 million joules. Okay, that's the kinetic energy. Your speed is 4 meters per second. Now, if you want to solve this, you substitute. Kinetic energy is 2 million joules. So you write 2 million is equal to half times m. What's the mass? The mass is m. The mass is not given. Times v. Your v is 4, right? So times 4 squared. Now, when you square 4, that means you have 2 million equals to half times 4 squared. 4 squared is 16. Half times 16 times m. Yeah, I just brought the numbers together and put the alphabet in front of it. Half times m times 16 is the same thing as half times 16 times m. So now you have 2 million is equal to half times 16 gives us 8. So you have 8m. So if 8m is equal to 2 million, how you get the value of m? Divide both sides by 8. Now if you divide 2 million by 8, you have m equal to 2 million divided by 8. 20 divided by 4 is 5. 20 divided by 8 is 2.5. Okay, so you have 250,000 kilogram. Yeah, that should be the mass. 2 million divided by 8 should give us 250,000. Question 5. Calculate the speed of a car of mass 1,200 kilogram if its kinetic energy is 15,000 joules. What will you do? You write the formula for kinetic energy. Kinetic energy is half mv squared. What's the kinetic energy? Kinetic energy is 15,000 joules. So you write 15,000 here. Let me conserve space. You write 15,000 here. 15,000 equals to half times, you don't know the mass, so you write m times the speed is what? Oh, sorry, we know the mass. The mass is 1,200 kilograms. So you write half times 1,200 times, we don't know the speed, so you write times v squared. So that means 15,000 is equal to half times 1,200 will give you 600. So that will give you 600 v squared. Now take note of this. If 600 v squared is equal to 15,000, how will I get the value of v squared? I will divide both sides by the coefficient of v squared. Hence, I'm dividing both sides by 600. Okay, 600 v squared divided by 600, that will give me v squared. Okay, so v squared equals to 15,000 divided by 600. Let me take this step by step. 0 cancels 0. 150 divided by 3 is 50. 50 divided by 2 is 25. So v squared equals to 25. If v squared is equal to 25, how will you get the value of v? Take the square root of both sides. Yeah, you know, you are looking for speed. The question says calculate the speed of a car, not calculate the square of the speed. So to get v, you take square root of v squared. Okay, so when you take the square root, what happens? This is what happens. The square root will cancel out. The square root will cancel out this square. Okay, so on the left hand side, you will be left with v. Okay, and the square root of 25 is 5. Hence, your answer v equals to 5 meters per second. Easy, right? Good, of course. Easy. Question 6. Calculate the speed of a ball of mass 400 grams if its kinetic energy is 20 joules. Of course, you can solve this. Use the same formula, kinetic energy. Let me return to the blue ink. Okay. Yeah. So, sorry. So, kinetic energy equal to half mv squared. What is the mass? The mass is 400 grams. Do you use gram in physics in this topic? No, we use kilogram. So you convert to kilogram by saying 400 divided by 1000. Hence, you have your mass as 0.4 kilogram. What else do you need? Nothing. Now let's substitute. Kinetic energy is 20 joules. So we substitute for kinetic energy, okay? We substitute 20 joules for kinetic energy. So you write 20 equal to half times mass. The mass is 0.4 times, what's the speed? The speed is unknown. So you write it as v squared. Okay, the speed unknown. The speed is what we are looking for. The question says calculate the speed. So the speed is unknown, okay? Yeah, so whether speed or velocity, we use the symbol V to represent speed or to represent velocity. All right, let's go. That means 20 is equal to half times 0.4, you get 0.2. So that's 0.2 V squared. Let me complete the question here. If 0.2 V squared is equal to 20, how do you get the value of V squared? You divide both sides by the coefficient of v squared. Okay, so you divide both sides by 0.2. Now, when you divide both sides by 0.2, 0.2 will cancel out 0.2. So on the left hand side, you'll be left with v squared equals to 20 divided by 0.2 will give you 100. The question does not request for the v squared. The question requests for speed. The question requests for v. So to get v, you take square root of the left hand side and you also take the square root of what you have on the right hand side. Square root of v squared gives you v and square root of 100 gives you 10. So you just put your SI unit in front of it. 10 meters per second. That's the speed. Easy, right? Of course it is easy. So now there's no answer. These are not the answer. This is your exercise. So now this is an exercise for you, okay? So you can pause this video now and you solve all these questions. Okay, take note that in question number 1, the request for your kinetic energy and you're given the mass and you're given the speed. So just use the formula for calculating kinetic energy to get the kinetic energy in each of these in the first case. Okay, the second question, you have to calculate the mass. Okay, you have the kinetic energy, you have the speed. So the third question, of course, you calculate the speed. Okay, you are given the mass, you are given the kinetic energy. Question number 4. Question number 4, the only thing you have to do, you convert your kinetic energy that you get, just express it in kilojoules. That's all. You have the mass, you have the speed. When you get your kinetic energy, convert it to kilojoule by dividing by 1000. Okay. And in question 5, when you calculate, or you have the kinetic energy, you have the speed. Calculate the mass. The mass you get is in kilogram. You have to convert it to grams. Okay. Take note that if you are converting from kilogram to grams, you are going to multiply the value you have by 1000. And if you are converting from grams to kilogram, you are going to divide the value you have by 1000. Okay, so when you get your answer in kilogram, to convert to gram, just multiply it by 1000. You get your answer in grams. So when you pause this video and solve all these questions, and then you come and compare all your answers with what you have here. Okay, good. So I remember I talked about I just having a brief review. I talked about falling objects, okay? That when an object is falling from a table, at the top of the table, the object possesses gravitational potential energy, okay, but it has zero kinetic energy. Okay, while it's falling, midway in its journey while falling, it possesses both gravitational potential energy and also kinetic energy. Okay, midway in its journey, its gravitational potential energy and its kinetic energy are equal. Okay, and when it's about to land, its gravitational potential energy is zero. Why? Because the height is equal to zero and gravitational potential energy is mgh. So when h is zero, then gravitational potential energy is 0. And all its gravitational potential energy at the beginning has been converted to kinetic energy at the bottom just before landing. Okay, so that is what the conservation of energy is. So physics lets you know both what is happening and why it's happening. That's one beautiful thing about physics. Okay, you know what and you know why. Yeah, so that is physics for you, okay? And take note that exactly midway in its journey, half of its journey, its gravitational potential energy will be equal to its kinetic energy, okay? If in the beginning, all the energy was 15,000 joules. So midway in its journey, its gravitational potential energy will be what now? Midway in its journey, its gravitational potential energy will be 7,500 joules, while the kinetic energy will also be 7,500 joules. Okay, and when it's about to land, its kinetic energy would be 15,000 joules. Okay, with the assumption that energy is all its gravitational potential energy is converted to kinetic energy. So with the assumption that there is no drag, but take note that in reality, this object is falling in the presence of air molecules, okay? And air molecules will introduce drag or air resistance. So due to drag, its kinetic energy at the when it's about to land will be less than this value, okay? The kinetic energy will never be equal to gravitational potential energy in a real life setting, okay? Yeah, in a real setting, some energy would have been converted to heat, okay? When you try to draw the Sankey diagram of the system, you have to include the energy that is lost in form of heat, okay? While at the end, you have kinetic energy. In the beginning, you have gravitational potential energy. And along the line, some energy has been lost to heat and sound. Yeah, when something is moving in the air, it produces sound. You hear such sound when something is moving in the air at high speed. Though most times we don't consider the sound to be of significant importance. Why? Because most of the energy converted is heat energy. And by the way, even sound energy would be converted to heat energy at the end. Yeah, sound energy will be converted to heat energy at the end. And this is what the graphical representation of energy conversion is. Okay, if you follow the green line, if you follow this green line, you see that at the beginning it's the gravitational potential energy is maximum, and while it's falling, the gravitational potential energy begins to reduce and reduces to zero when the object is about to land. But at the top, when the object is at the top of the table, its kinetic energy was zero. Okay, once it starts falling, as it is falling, gravitational potential energy begins to reduce while kinetic energy begins to increase. Okay. Kinetic energy increases till the body is about to land. Okay. And when it's about to land, its kinetic energy will be maximum, while the gravitational potential energy will be zero when the object is about to land. Now, this is a question, it has even been solved. So this question I wouldn't be explaining, okay? I want you to just go through it and learn it at your own pace, okay? Just pause this video now and look at this question and go through it. Try to understand what was solved. Okay, now that you are done with that, let's talk about power. Power is the time rate of change of energy, okay? Or you say power is the time rate of doing work. So power equals to work divided by time. Okay, take note that the SI unit of power is watt. The SI unit of work remains joules, time remains second. So power is work done divided by time. Okay, work done is force times distance. So you can say force times distance divided by time. Also, that same power is energy divided by time. That simply means you can say power equals to kinetic energy divided by time. Also, you can say power equals to gravitational potential energy divided by time. Okay? Okay? Any form of energy, be it heat energy divided by time. Once you divide energy that flows by the time. You get the power. This is an example. Calculate the power of a motor that exerts a force. You have the force of 40 Newton over a distance of 10 meters, 2 meters rather, for 10 seconds. What's the first thing you do? You calculate the work by multiplying force by distance. When you multiply force by distance, you get 40 joules, right? Then you use the formula for power. Power is work divided by time. So you divide this 80 joules by the 10 seconds. Okay, so 80 divided by 10, you do that here, you get 8.0 watts. Easy, right? Good, very easy. Now, this is a question. We solve this question ourselves. A boy applies a horizontal force of 1.5 kilonewton. Well, the way I like to do it, I will find the value of my force. The force is 1.5 kilonewton. How do you convert from kilonewton to newton? You multiply by 1000. Yeah, that's how you deal with the kilo. You get 1500 newtons as the force. What else do we have? A boy applies a force of 1.5 kilonewton in pushing a car through a distance of 0.25 kilometers. D equals to 0.25. You know, we have to convert from kilometer to meter. How do you convert? You multiply by 1000. Take note that mass is the only thing that must be expressed in kilo. Okay, mass must be in kilogram. Every other quantity, you must express it as the normal unit. So 0.25 multiplied by 1000, you get 250 meters as the distance. And we already have our G to be 10 Newton per kilogram, right? Good. Now, if it took him 2 minutes, your time is 2 minutes. How do you convert minute to second? You multiply by 60. So your time is 120 seconds. Okay. Now we can solve the problem. Calculate the power. Power equals to work divided by time. Okay. How do you get work? Force times distance. Okay. Good. Force times distance, all divided by time. Okay. Hence, we can say our power equals to force. What is our force? 1500 Newton times distance. What's distance? 250 meters divided by time. What is time? I don't have to put these meters here. Divided by time. What is time? Time is 120 seconds. So you do 1500 multiplied by 250 divided by 120. So let's do that here. 1500 multiplied by 250 divided by 120. That gives us what? No, I divided by 1200. I should be dividing by 120. 1500 multiplied by 250 divided by 120. That gives us 3125 watts. So our answer is, oh, come on. Our answer is 3125 watts as the power. Easy, right? Good. Very easy. Let's solve the next question. Calculate the power of an electric motor that lifts a mass of 50 kilogram. So our mass is 50 kilogram upwards by 3 meters. Our distance is 3 meters and our time is 20 seconds. Hence, we can calculate our power by saying our power is calculate the power. Good. Power is you can express power as energy. Okay, we can express power as energy. Okay, and the energy used in lifting something upwards, you can express that energy as the gravitational potential energy. You know, when you are lifting it upward, you are lifting it and giving it a certain height above the ground. So you are storing up gravitational potential energy as you are taking it up, okay? So you are storing up gravitational potential energy. So you can express our power as gravitational potential energy given to the mass. Okay, you divide it by the time taken. Okay, good. So our power equals, what's gravitational potential energy? mgh, m times g times h divided by t. Let's go. What's our mass? Our mass is 50 kilogram. Okay, mass of 50 kilogram. What's gravitational field strength? G is always 10. What's our height? The height is the upward distance, okay? A distance of 3 meters. 3.0 is 3. What's our time? Our time is 20 seconds. 20. So the power is equals to 50 times 10, that's 500. 500 times 3, that's 1,500. 1,500 divided by 20, you get 75 joules. No, power is not measured in joules. Power is measured in watts. 75 watts. Easy, right? Of course, it is easy. Let us solve the next question. Oh, okay. So this is it. Okay. You can proceed by calculating the gravitational potential energy first. Okay. And then you divide energy by the time. You see, end up getting the same answer. Now, this is a classwork for you. Okay. This is your exercise. Okay. In question one, you have to calculate work done. You are given the energy, you are given the time, and yeah. Also, you calculate the power as well. Yeah, you calculate the power. I'm sure you know what to do, right? I want to believe you know what to do. Or you want me to solve question one as an example? Okay, let me solve question one as an example, okay? Why you solve two, three, four yourself. Now look at question number one. Power equals to work done divided by time. Okay? If you introduce a denominator of 1 here and we cross multiply, what will you have? You have work equals to power times time. Okay, now let's substitute. What's our power? Do you have power? No. Do you have energy? Yes. Do you have time? Yes. Okay, that means you don't even have to do this. Okay, you just go ahead by saying power equals to work divided by time. It's even easy. I don't need to do this. I don't need to do this for you. Okay, divide work by time. Do you have work? No. What do you have? Energy. Fine. Power is also energy divided by time. So let us erase work from here and put energy here. And what's the energy? The energy is 600 joules. 600 divided by, what's our time? The time is 120 seconds. 600 divided by 120, that will give us 5. 5 watts as your power. Okay, so you just put 5 here. Easy, right? Yeah. The next question request for the work done. How do you get work done? Power is equal to, I don't even need to do this. Energy stored in the object is used in doing work. Hence, since energy stored in the object is used in doing work, we can say the energy equals to work done. Easy. Okay, or you say the work done equals to energy. Easy. Hence, the work done equals to 600 joules. Okay, these two columns will always be equal. Energy and work, they are equal. Okay, so energy will always be equal to work done. Yeah, so in fact, this is even the easiest table to solve here. Okay, these two will always be equal. These two will always be equal. Easy. So once you get one, just put the value in the other column. That's it. These two will always be equal. Do not forget that kilojoule must always be converted to joule. Okay, so when you solve this question and you come and compare your answer with what I have here, okay, you can see that the values are equal, the values in these two columns. So please don't look at the answer, pause this video and solve all these questions. Okay, that's how you know if you have actually learned here. Okay, you have to pause this video and solve all these questions, please. Yeah, so I want this to be the most engaging video. Okay, you have your classwork, you have your activity, pause the video, solve all the questions, and when you're done solving, you come and compare your answers with this. If you have made any mistake, then you know you have to go back and go through all we've discussed so far. Okay, you have to go through all the examples again and try to understand the steps. Okay, yeah, that's how you learn. Okay, that's what you mean when you say self-taught. You have taught yourself, you have learnt yourself, you have fought the battle yourself, and you are finally a victor. Okay, so I've talked about this already. If you want to calculate the total height, you will multiply the height of each of the stairs, okay? You multiply the height of each of the stairs by the number of stairs, okay? In this case, now how many stairs do we have? 1, 2, 3, 4, 5, 6. So in this case now, the number of stairs is 6. So you just multiply the height of each of them by 6, okay? That will give you the total height. And I remember we have solved questions on this. That's what this is just trying to let us know, okay? Good, good. So this is an example. um, I'm not gonna do this because we've done so many examples like this. The question is not given, it's just a walkthrough for you to understand the step I took in the example I took. Now look at this, let the weight of the person be 800 Newton and the time taken to climb all the stairs is 3 seconds. Now, the number of stairs is 12. Okay, we assume the number of stairs is 12. Though if you count, you get 6. But let us assume it continues and the total number of stairs we have is 12. And the height of each of them is 0.2 Newton, 0.2 meters rather. So that means the total height will be 12 times 0.2. That will give you 2.4 meters. That's the total height. How do you get work done? MGH, okay? No, since you don't have M, we have the weight, okay? So you don't have to do MG. Just multiply the weight by the total distance. That will give you the total work done. So multiply this weight by the total distance. You know the total distance is your height. So multiply the weight by the height. That's how you get the work done. So you get the work done as this. So to get the power, just divide the work done, okay? The work done, divide it by the time. And what's the time? The time is 3 seconds. So divide the work done by 3 seconds, okay? You get the power. It's easy, right? Yeah, of course it is easy. That's physics for you. Physics will always be easy as long as you create time to study physics. So that is it. And yeah, that's it. That's all. So thank you for listening. Ensure you do all the activity given to you. Okay. Yeah. So in this case, you can learn it on your own. You don't need anybody to teach you. If you don't understand it, go through the video again. Watch all the steps I've taken again. Trust me, it will be very enlightening. Yeah, it will actually let you understand this concept of work. You get to understand work very well. You get to understand energy conversion of energy diagram, the Sankey diagram. You get to understand power, okay, how to solve questions on power. Okay, do not forget that when we're talking about energy, we talked about kinetic energy. We also talk about gravitational potential energy. I just mentioned chemical potential energy, though we couldn't solve questions on this, okay? So usually physics will try to avoid questions involving chemical potential energy, okay? So as for other forms of energy like heat energy, the elastic energy, okay, elastic potential energy, all of this you'll be solving. And when you are taking questions on heat capacity or specific heat capacity. Also elastic potential energy, you solve that when you are solving questions on Hooke's law, okay, when you're given the formula half K squared or half FE. So that is it. And your heat energy is mass multiplied by your specific heat capacity, then multiplied by change in temperature, or you say theta 2 minus theta 1. So that's it. This is just a brief revision video for those that will be writing the IGCSE, WAEC, NECO, EQA, EdExcel, and other physics exam. Thank you for listening. It has been a nice time having you here. Ensure you have a nice day and ensure you study very well for your exam in order to make very good grades. Do have a nice day. Goodbye. See you in the next video. Thank you.